Normally I start off with this screen right here. And the reason why I didn't start off like this is because I fucking forgot that I had to press the start stream button manually. It's okay, yeah, none of the value was lost because I was basically talking about like how I got this idea while eating taco or something, so you didn't miss any. I was just speaking some stuff, yeah, for 18 minutes without the stream was on, without the realization, but it's okay, it's okay. Shit. Okay. Okay. It's okay. Yeah. There's actually some important stuff that I have to re-say it again. Yeah. So I have from the last stream, to the Pendulum live stream, we left off by making an attempt to create the animation, the pendulum 2D pendulum animation, and it didn't go quite well. I was totally alien to the Python or coding stuff, and even the ChatGPT didn't seem to provide me some helpful information. So after that stream, I actually searched it out more. I just basically asked ChatGPT more how to actually make the animation possible, and I got some refined codes, and so I basically fixed the codes, and I have that animation right now, and I'm going to show it to you guys right now. Okay, where did I save that thing? Jesus. This one, yeah. So I'm also going to upload this in the YouTube community post afterwards, and I'll also attach this file, this GIF file, into the membership page. Yes. So speaking of membership, if you join my membership, you'll be able to gain access to the files that I used on every live streams. So, for example, for today's live stream, you'll be able to gain access to the Krita file that you're watching. Yeah, this one, Krita file right now, and also including this one. So if you're interested in gaining access to the files that I used on live streams, please consider joining my membership. I'm really glad. Thank you. And in case if you don't know, what Krita file is that I keep talking about is that is this, which is a drawing software, basically a Photoshop. The name is Krita software, drawing software. Okay. So that being said, let's get right into it for today's stream. Okay. So, we got 3D pendulum. The 3D pendulum's speculated trajectory, which is in color yellow right here, I think this might be wrong. Because this one right here is actually not a string. In 2D pendulum's case, if it's a string, it's fine, but the reason why I am saying it's not a string but it is a like rigid rod, is to minimize the complexity as much as possible, because the motion of this 3D pendulum that I have decided to put right here is that the axis is spinning in a constant angular velocity, and I don't know, I just thought that it might leave some draft and even provide some unnecessary inertia among the motion, that it would yield some crazy like phenomenon, like the bending of the weight or something like this. So to minimize some crazy shit like that, maybe it's a good idea to simplify that it's a rigid rod. Okay, excuse me for a second. Okay. You can't point. I'm not sure. Actually eating. And like always, in constant silence between me speaking would indicate that I am eating something or stuffing something into my mouth. Okay. Oh. Since this rod is rigid, and it will definitely have a certain point that passes through the spinning axis, just like right here. It would always go through the axis, the spinning axis. So I thought that the actual trajectory would be like this. Okay, ignore all of these for now. Just focus into this one. Focus into this one. So I thought this is the trajectory from the upper view. Initial point from here. And if it's a normal pendulum, then it will resonate between here, and that will be it. But in this scenario, the spinning axis spins the trajectory of a pendulum. So this spins in this way. Okay, that's why the pendulum weight does not go from here to here, but it goes from here to here. Here to here. And the same way it goes from here to here, here to here, and here to here, and repeats. So yeah, I think this is a correct trajectory. And we're actually going to put that in mind and keep continuing. Okay. And I'm pretty sure you're not really curious about what are these slides is all about. I'm damn fucking sure. Yes, but I'm not gonna explain all of these slides for now, but if I have to feel like that I have to explain this, then I'll come back to these slides. You know what, I think I have to eventually come back to these slides because there were some certain things that might be very crucial. I don't know, maybe not. So anyway, 3D pendulum, and okay. My guess was right here that this is part of the oscillation right here, whole oscillation, and in every point, the weight will suffer through two types of forces, and one will be from the gravitational force, and one will be from the centrifugal force, which is right here. Yeah, the centrifugal force is where are the yeah, centrifugal force is equal to mr vector omega squared, and r vector omega squared I was kind of puzzled about the r vector part right here, because it was basically nothing, but the origin was here. So maybe was this the r vector, or was this the r vector? And I think this is the answer. This is the r vector that I have to consider about. So that is why it's the L and the theta. Theta is the angle between the rod and the axis. Welcome. Hey, you finally got the Korean hello. I'm really proud. I really do appreciate that. Thank you. Okay. The theta value is the angle between the rod and the spinning axis. Which is probably a thing that we have to do basically the same thing with the Jacobi elliptic functions or something, I don't know. And L sine theta, this value, this length is L sine theta. That is why r vector, the scalar value of all r vector is L sine theta. And that's why I input the L sine theta in the place of r vector. And omega square is the same. Okay. And yeah, of course, obviously, it is pointing outwards of the spinning radius, of course. And this is the part where I thought of something weird. First, I thought, for some unknown reason, I thought that the convoluted vector of these two vectors are aligned to the this line straight up right here. But that would not make sense, because when it comes to the normal 2D vector, then it will have a gravitational pull. It's the only force that exists that drives the pendulum to move. And this gravitational force is direction in this way, not in this way, but it divides into two components, just aligning to the line and normal to that line, which is this one right here. And this is actually what makes the pendulum go through the trajectory. So I'm basically applying the same thing into the 3D pendulum. So it should not align with this line right here. Okay, and this is what I draw in here for a better angle. As you can see, this line does not align with the convoluted force right here. And this is the point that we have to start from. Literally, I was holding on to this for like an hour ago. No, about an hour and a half ago. An hour and a half, 1.5 hours ago. And I slept like for like 20 minutes. And I cooked food, which is what I'm eating right now. Speaking of food, okay. First of all, this will, you know, wait, how am I supposed to do this? Yeah, this will, the force, this one, the, I'm gonna name it O. I want to name this, I don't know, F1. This might be not important. F1, okay. The vector, and F1 is pointing through here. And we want to know what this is. We want to know what that is. In order to know what that is, theta prime and theta. This angle is pi over 2. And pi over 2 minus theta. And I want to name this F2. Then the F2 vector would be the cosine of theta prime plus pi over 2 minus theta. Yeah. F2 equal to for now, I'm gonna ignore the directional part for now. I know direction might be very crucial, especially into the 3D pendulum. But for now, I'm gonna ignore it for now. F2 F1 cosine pi over 2 minus theta. plus theta prime. Okay. And theta prime, we can actually get the value of the theta prime. Theta prime is the inverse tangent of, oh god, okay, theta prime, tangent theta prime. Yeah, ml sine theta omega square over mg. Just to make sure that I don't make a mistake. Tangent theta prime mg. Did I enable the background music? Yes, I did. Okay. Background music is on. Okay. And then oh, and this is also hold on. F1 cosine I over 2 okay, which is equal to hold on, I have to remember this. I know what is this. One theta minus theta prime, right? I think this is what it is. Wait, is it right? You wanna play it, right? I think this is not right. No, wait a minute. No, this is right. This is, wait a minute, cosine pi over 2 is 0. Yeah, this is right. If it turns out it's incorrect and I have messed up shit and I have to do the same thing all over again, I'm just gonna not do it. I'm just gonna give up. Literally, I'm not joking. I am actually so tired right now, and I don't. Okay, here's the thing. I want to conserve my stamina. I cannot do like crazy live streams. Like that one time that I did, I spent like 6 hours. I think it was a cycloid on a cycloid. I could do that, but I think it's not necessary, and it's actually a downside. It's just like extending unnecessary amount of the live stream duration. Like make it clear, make it short, but make it very conveyable. Also tolerable, which is important. Okay, and this will be tangent inverse tangent of L sine theta omega square E. Right? Okay. L sine theta. This is the value of the F2, just the driving force that pushes the weight inwards. Okay. Let's see. So yeah, that is the main that is the main force that drives the thingy into the thingy. So I am going to hold on. Okay. Honestly speaking, I actually don't have a strict, solid idea about the next step, but maybe I should start from here. So this is this is wait, hold on. Can I simplify this even further? Oh, maybe I can. And why haven't I thought about this? Okay, F1. There's something wrong. F1 is equal to root of mg square plus ml sine square omega square. Yeah, and this will be n will go out. B square plus square sine square theta omega quadrant. Right? Yeah. This can go right here. But it doesn't simplify shit, but at least we got something, I must say. Yeah. Okay, maybe I want to explain this one. So while I was searching on GPT okay, about the centrifugal expression, I was able to get the information about the rotating frame and the inertial frame. So I'm not going to elaborate much deeper into this, but the point is, the concept is the inertial frame is the basic frame, the basic world that we see in our perspective, just default perspective. And the rotating frame is just basically a carousel. You're standing in the carousel, and you're looking at the carousel world. So, which means that the carousel is a... Okay, I have a depicted very thoroughly through here. Hold on, let me show you. This one right here. Yeah, okay. So the carousel is spinning. The carousel is spinning. But in Mrs. Patton's perspective, the carousel is spinning, of course, yes. But in Mrs. Dampot's perspective, the carousel is not spinning because he is spinning at the same time, just standing still. So for clear demonstration, I admit, okay, I have to confess this is also the same idea that GPT provided. Yes. But I don't give a shit. So, Mrs. Patton's perspective, when you roll a ball from the center of these the shit I just do. Okay. When you push the ball from the center, then from Mrs. Patton's perspective, of course, it's a ball is rolling further away from the center, but it might be look like the ball is going through the spiral trajectory into a spiral motion. But on the other hand, in Mr. Danpat's perspective, right here, of course, it is not moving in spiral. It is moving just into a straight linear line outwards from the center. You see this going further, and this is how Mrs. Danpot sees the ball is going. So yeah, this is the rotating frame on the right rotating frame, and this is the inertial frame. Yeah, so that's basically it. And God, do I have to really tell how I got this? No, I'm not gonna do that. Yeah. So, okay, hold on. And no, I'm not gonna do that. Okay, so the F is equal to m rod. The rod is rod indicates the rotating frame. Yeah. So whenever there's a ROT next to some, I don't know, letters right here, especially this one, this is the acceleration according to the rotational frame. And as you can see, this doesn't have ROT next to the letter, which indicates it's an inertial frame. Okay, so I'm not gonna explain this, but it will not matter for their progress. Okay. So I'm going to use that expression and plug the F1 into there. Maybe it will yield some results. Okay. Okay. Hmm. Hmm. Man, I cannot wait to ask this exactly into ChatGPT. I cannot wait that moment. But yeah, like I said, I'm gonna ignore. No, maybe I should not ignore this one right now because it's actually scary. Not gonna lie. You know what? Maybe not. Yeah. maybe I should not ignore. Oh, hold on. This vector kind of stuff is really clinging onto my brain. Like, it's baffling, very baffling, and also scary. I think I didn't have to think about much about vectors while I was thinking about the 2D pendulum. Thinking with 3 dimension, always brain boiling moment. It's always hard to describe inside your brain. Always requires a full potential CPU 100. Of course, I'm talking about my brain. Very difficult thing to do. So, going. Oh, what would be? Yeah, this is the direction. Right? This direction. Uh, okay. Here's the idea. I'm gonna make the unit vector. Oh shit. Yeah, I'm gonna make the unit vector in the direction of the F2, and there will be symbols. There's symbols. What symbols are there? Unit vector. I don't know. I'm just gonna so A B C D E F G H I J K. I'm gonna name it U. Yeah, U. Unit vector, which is a direction unit vector to a unit vector direction F2. Yeah, okay. And then we can plug it in. So F1 minus engine. I don't know, maybe this is like not way easier, but slightly easier than I have imagined, because in the end, all those like complex and complicated things just comes down into a simplified forms for mere human mortals to understand. Maybe this is one of those things. Okay. Yeah. In the 2D pendulum, the concept of Jacobi elliptic functions was derived while I was thinking about the nonlinear derivative equations. And I believe the actual solution was not even making an attempt to solve the nonlinear differential equations. But maybe this will yield the nonlinear. I don't know. I have no idea. Definitely yield some differential equations. I'm pretty sure about that. Which one will be is I'm not quite sure about it. Okay. Oh, this problem. Okay. Oh. And M will go away. M, let me just tag it with the color red. M can be ignored right here. This might be also important. What is important? That in the rotational frames, in the rotating frames perspective, then the trajectory is just a 2D pendulum, basically. It will be not like this, but it will be something else. It will be. Okay, it will be. Blue ball right here. Another blue ball. Here. Another one. It will be a normal pendulum, but the trick is it definitely would not follow the ordinary default 2D pendulum's trajectory. But it will move like this. Yeah, it will move like this. With the... Hold on. Okay. So there's a trajectory right here. Omega, the angular velocity into this direction. Rotating, right? Oh, and by the way, this is totally out of the blue information. The thumbnail, which is a recolor version of this. I created this in Blender. It's kind of obvious, but I created this in Blender. I really wanted to say that. As if I wanted to, like, get acknowledgement or even a praise that I did a great job. It's just such a sad fact that when you get old and older all the time, that you'll get less opportunities and chances to hear some praises from other people. As if like other people are like just expecting you to do the required things. Such a very shadowy, gloomy fact. Why am I talking about this right now? Rotating frame. And the V would be here. I might be able to simplify this for some reason, because the V would be this will be the direction of the V rotating. Oh, wait, what was it? Yeah, that will be the direction of the rotating velocity of rotating frame. I'm pretty sure. Yeah, I'm pretty sure. And that will be. Hold on. Then the omega and the V rotating frame. Omega and V rotating frame. Oh right, this is also theta. Interesting. Okay, that's also a value of theta. Which means that this angle right here would be... Oh, I'm thinking too much right here. Hold on. This is theta. Theta? Yeah, there's a theta. Yeah, I think I know how to do this. Omega and omega. Okay. Omega. 벌써 하기 싫은데? 잠시만. This is the theta. This is theta. When I do this, this is also theta. Also theta. And this will be pi minus 2 theta. Pi minus 2 theta. And I add a theta. That would be pi minus theta. Yeah. That was so difficult to understand. Well, why? Okay, so this was theta. Theta is theta. Pi. The whole pi right here. Pi minus theta. Okay, pi minus theta. Pi minus theta. There we go. And I believe if I do this, then it will yield a omega and v. This one can turn into 2 times 2 omega v rotational. V rod rotating frame sine pi minus theta. And I want to name this. Okay, I'm gonna. U2. Okay, I'm renaming this unit vector U2. U2, and this will be U1. This will be U1, and U1 is going through the paper. Direction is going through the paper. Unit vector U1. Okay. Yeah. U. Okay. When the theta value goes to minus, right? Because that's the positive value of theta, but it will eventually rotate between positive and negative value. And when the theta becomes negative, then it be sine pi minus theta. The pi minus theta exceeds over pi, and the sine value will be minus, which is it will flip the direction. It will flip the direction, and it will eventually point towards to you watching right now. Yeah, it will be this direction when it gets flipped. Right? Yeah, it does. So confusing right now. Okay. Zero equals to B rod. Zero again equals to. Okay, and this will be 2 omega. Okay. the rotating sine. What's sine pi minus theta is a sine. What about oh, the sine theta is just basically sine theta. Okay. Right, sine pi minus theta. This sine theta. Okay. And acceleration. No. R and omega square. Okay. I'm real confused, but okay. Maybe this is not okay. I mean, seriously, I don't know. Well, what further steps that I should go from here is really questionable. 피곤해. Hmm. 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 Hold on. I might need a thing. What is this? You can move, drag, and rotate control scroll left to the control click left to the item to flip it. 씨, 뭐야 이거? You can move, scale, and rotate items. Depending on item with lock mode, just drop it on here. Double time to lock it in place. You can allow items to name enough for drag items from the Holy shit! You guys don't have to see it, but this jump scared me to shit. I couldn't believe it. What is this? Oh. Okay, this is not what I am expecting to happen, but yeah, this is not what I had in mind. Wait, how do I do this? Oh, will. Oh. This is not what I was supposed to have. It's okay. This is not what I had in mind. I know that I have imported the YouTube buffering symbol into the item list. And yeah, here we go. So I think I need this for right now. The main reason why I have stamped that shit right over my forehead is because I think I need some time to regain my motivation to move on. This shit is crazy. This is crazy shit, I must say, and crazy shit requires some rest. Yeah, of course, some rest and some rejuvenation. Okay, excuse me for a second. My god, I think I was kind of famished for today's live stream. Like, I could not get enough of hungerness. Sometimes it like scares me to a degree that if I have a parasite in my stomach or something, it scares me. Did I froze? Oh shit. What now? Okay, there we go. Hmm. Okay. What else do I have? Mm, mm. Oh yeah, I had this. How could I forget about this? Man, the good old days. Okay. Where was I? Control click. Oh, there we go. Yeah. The good old days that when I was new to YouTube Studio. I was basically doing everything that I could to find some more fun and entertaining. Hmm. They still slap though. It's good. It's gold. It's gold actually. Okay, so I really want to refrain myself from moving into the ChatGPT tab because that's a thing that I really want to avoid. So, as you can see right here, this U2 value right here, uh, unit unit vector. It's a unit vector, and it's shit. Where did it go? Yeah, it's this is from the top view, from the top perspective. It is not pointing through. It is not pointing through here. It is actually pointing through here, and to make that possible, I think. Oh god, I think like I said, this run right here can be simplified into these terms. And this vector and this vector right here needs to compensate each other, more like dissipate each other, and to make the unit vector u2 go headed into this direction, into the center. If I'm doing this correctly, I think this is what should I do. Right? So yeah. You know what? Maybe not. Maybe That's not what I'm supposed to do. Maybe this left-hand side is wrong in the first place. Okay. Oh, jeez. mg and downside ml science omega squared. Okay, centrifugal force. Maybe there's a one more force. I think there's a one more type of force, and that is making it move. Making this thing move into this direction. Rotate according to the origin right here. Yeah. I should have thought about that. And then oh god. and then what would be the torque, right? Or like torque. How? Like this. Yeah. It was also something kind of like this, right? IA, and I was the rotational inertia, which was equal to this. I forgot. I have to. There's always some feeling these things. I'm gonna ignore this gut-wrenching feeling and move on, and just gonna pretend that there's nothing wrong with here. Okay. This is this one is actually pointing inwards to the inwards. In the center, of course. The A rotation value to the inwards. Yeah. Yeah. R would be, you know, okay, then by the way, I already said that if I'm being too quiet, and it indicates that I'm stuffing some food into my mouth. Actually, right now I'm not. I already have finished it. I'm not stuffing food into my mouth. I'm just exhausted. That's it. I just couldn't get the feeling. Just couldn't keep out the feeling that there's something missing. Something is off. I have one sign. No, two. What is the angular acceleration of what do they call? Constant speed, constant rotation, constant rotating circle. If a circle is rotating at a constant angular velocity, then its angular acceleration is 0. Yeah, okay, here we go. Now the depending on ChatGPT arc is starting. Welcome to the episode Pararang relies on the AI feature once more. Welcome. Okay. When a ball is attached to a spinning disc, then what kind of force does a ball receive? Ignore air draft, friction, etc. When a ball is attached to a spinning disc and all external resistance like air drag and friction ignore, the ball experiences the following forces. Centripetal force, a real force. This is the real inward force that keeps the ball moving in a circle. It is provided by the tension or constraint attaching the ball to the disc. Example: Magrutia, glue, string, rod, etc. Direction towards the center of the spinning disc. Yeah, magnitude is that shit right there. I know what that is. That right there. I think that's important. Tangential force, only if angular velocity changes. Never mind. If the disk's angular velocity is changing, the ball will also feel a tangential force due to angular acceleration. This causes a tangential acceleration, which is not my case. Okay. If the rotation is constant, what? Alpha is 0 and this force is 0. Note on centrifugal force. In the rotating frame, non-inertial, the ball would appear to experience a fictitious outward force called the centrifugal force, but this is not a real force, it's just a way to account for motion in the rotating frame. In an inertial frame, only the centripetal force is real. I know that. Summary: if the disc spins at constant speed, the ball experiences only centripetal force inward, no tangential force, no net force outward. Centrifugal force is fictitious and inertial frame. Okay. So, I think what I have done is correct, right? So far it's correct. Shouldn't be like this. But yeah, it seems like it's correct. And I don't know, it's very weird. Very, very weird. Ooh. Uh, oh, come on, I can't do this without relying on ChatGPT. My math skills cannot be this bad. I don't know how to describe this, but there's a kind of feeling. There's a firewall blocking the synapses. It's interfering with my thought process. Oh. Oh, wait a minute. Am I going through? I think I'm going. I think I'm going through. I think I'm going through. No, wait a minute. No, I don't think I'm going through. I think I'm going through. I think I'm going through. Okay. So the direction of the rotating frame, acceleration of rotating frame direction points the inwards, like a centripetal force, and this shit right here is actually important. Yes. So it excuse me. Its direction. Its Oh, what's the word? Orthodormic? What was the word? Ortho, orthogonal, right? Yeah, it's orthogonal to this plane right here. What did I just do? And and the sum vector, the vector sum of these two vectors will be like it'll be pointing into this direction, but it's not actually not aligned, not part of this plane right here. It is okay. Imagine this paper, and if I add these two vectors, then it will be like this shit right here. It will be like something kind of like this, or something kind of like this. Yeah. And okay, I might so paper right here. This paper is this paper. This whole gigantic paper. And this will be the U1 rotating frame vector, and this will be also U1 rotating frame, but in a different theta value. And this would be the direction of the acceleration of rotating frame. Then those sum will be either this or that. And if we combine this, if we combine this with the R vector, which is an inertial frame, then it will be something kind of like this. Is the spinning axis, and the ball, the blue ball right here, the blue ball. Okay, your favorite blue ball right here, and I'm guessing. What I'm guessing is that oh, this is also not the highest point or lowest point. This is the midpoint on the oscillation, and it will go kind of like this. Oh, it's really difficult to imagine inside my tiny brain. Help me. It will go kind of like this. Okay, I might have to tag this differently. I'm gonna tag this. I'm going to tag this, and I'm also I'm gonna tag this, and this will be some vector, and this will be the R vector, the inertial frame R vector. And if we sum up those two vectors, then it will lead to the U2 vector, which is what I thought that it is possible. It is definitely possible like this. Okay, which is yeah. No? Yeah? Jesus Christ. 이게 맞냐? 이거 아닌 것 같은데 이거? 모르겠네 진짜. 뭐가 왜 이렇게 이상하지 이렇게? This U2 vector, this U2 vector is pointing toward the center. It is pointing towards center, and to make that possible, I think some regulation should be made. Yeah, this is my just pure imagination, and I don't know, but this should be it. It should be like this to make it possible. Okay, it will be like this, and some vector of those two vectors will be this one, because this is the R vector right here. Okay, and this is the direction of U2, which is parallel to that pink one right there. And I think this is what is happening right now. This is what it is. Okay. Oh, a rotating frame, and that is that. Yeah. Okay. We might want to know. I'll portray this as the components, right? I gotta admit, I was actually avoiding to do that because now this expression will elongate to 7,000 lines that I have to somehow solve, and I don't like that. Excuse me. Okay. Oh. That's... Did I got it right? R omega square to omega v rod sine theta u1 rot a rot equals to the crazy thing, right? Okay. U2. We'll think about U2 first. U2 is a vector. Okay, U2 is a vector, of course, and it will U2 will be, well, U2x. Okay. U2x U2y U2z components, and they differ all the time, right? Yeah. And a rotation would be I'm going to rewrite this. Okay, I'm just gonna write it AR. Okay, ARX. ARX. E. AR. X, Y, and E. In the rotating frames perspective, it is moving in XZ plane. XZ. Okay, it is moving in XZ plane, which is ARY is 0. Yeah. So this just is a nothing. Okay. XZ plane. Yeah. XZ plane. And the hold on. This one is sine omega t plus sine omega t. Oh, whoa, 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 whoa. I don't know what I just did. If somehow I am able to crash this Krita software with this amount of progress, I'm not gonna be mad. I'm just gonna be like disappointed about my PC's performance. Severely disappointed. Okay, I think this is correct. Yeah. Okay. Okay. And E to Z will be just K vector without nothing else. Yeah, right? No. Oh, okay. I apologize for frequently being silent, but I occasionally have to have some moment to clear my mind and focus. Like, if there's only way to portray what my brain is going on and what kind of thought process I'm going through, and I can actually show this. If there's any way that I can show this on stream in real time, and then it will be like some crazy electrical bubbles with the density of million just popping up in every square corners, and it'll be like that. It'll be disgusting, but also very beautiful to look at. No. Oh. Okay, I think I'm ready. And this is basically it. And U2 and U1 are U1 rod, U1 rod, U1 rod, E U1. This is going to be U1 X plus U2X. No, the hell am I doing? Yeah, see, this is what I just talked about. The electrical bubbles and sockets particles popping up like the one scene from Oppenheimer is constantly having chain reaction inside my brain, and it sometimes eats my brain itself, and it gives a very crazy, what do you call it? Brain freeze, brain fart, whatever that is, and it's killing my brain. I should be really careful. Yeah. Okay. And U1 would be in this direction, in these both direction, these two. Which is in the rotational terms, in the rotation frame. There would be no value of these two, right? Because it's only existing in this y-axis, which is the EY axis. Right? Omega and V. Innards or outwards? Innards or outwards? Okay. Yeah, I think I'm right. I think I'm right. Innards or outwards? Ecstasy. Okay. And it is a equal to, oh god, what was it? Cosine omega t with the j minus sine omega t with the I vector. I think, yeah, I think this is correct. Yeah, okay. And what we have is R vector. Oh shit, that's going to be really difficult to do. R vector, I don't know. I'm just gonna. R vector would be Rx. J plus R D K. I don't think there's a perfect way of describing that, so I'm just gonna leave that be. Okay. There's seriously no way to simplify this? This shit's crazy right here. Okay. Just simplify all this crazy shit right here into I don't know. Let's just say Q. Yeah, Q. We're gonna name it Q. Okay. Q U2 X uh, U2 X I plus Q U2 Y J plus Q U2 Z K is equal to, oh, you gotta be kidding me right now. No, there's two. Okay. A R X cosine omega sine omega t I plus A R X sine omega t J plus A R Z E D. No. Hey. Plus 2 omega V rotation. Wait a minute. What even is a V rotation? Okay, I'm just gonna leave it be. I'll be able to find it out later. And sine theta. Yeah. U1y cosine omega t j minus 2 omega v rotation sine theta u1y sine omega t I vector. This might be fairly easy if I not fumble up on it. Okay, and plus omega square r x I, okay, plus r a vector plus r z a vector. Oh. And I think that will be it. Yeah. That will be the definition, if I must say. Okay. Okay. Wait, the unit vector, they're all one, right? So I can ignore the ones right here, of course. They're all one. No, wait a minute. They're not one. They're Oh, okay. This is a problem. U1Y would be 1. And I'm not sure about the U2 vector though. Man. The U1Y would be U1Y. Unit vector. Like this. Okay. Unit vector. Color value is 1. Means this one should be 1. This one is like this. U1Y is 1. Okay. Thankfully, we can abbreviate this. Yeah, we can turn this into 1 and delete that. U1Y. There we go. I'm gonna compile the I components, the each vector components, and try to find out if it leads somewhere else. Okay. I would be and I value q u2 plus q2x plus array. Wait a minute. Oh yeah, never mind. Okay. I thought the ARX might be 0, but maybe not. Plus a okay. I value, only I value. Minus. Oh, but it will turn into plus. Yeah, it will turn into plus if we move it over there. Does it also comply with vectors? Yeah, I think it does. I think it complies to vector. Yeah, I think it does. Okay. It'll be 2 omega plus 2 omega v rotation sine theta sine omega t. Minus omega square rx, and that's the component of I vector. Okay, interesting. Yeah, which means I should probably change this back into minus. Okay. And omega t plus 2 omega v rotating sine theta sine omega t minus omega square rx, and j component would be k u 2y minus arx sine omega e minus 2 omega v rot sine theta cosine omega t minus omega square ry, and that's the component of j. And final one, qu2z minus, did you have minus? Okay, minus arz, minus arz. Minus omega square rz. That's the component of the k vector. Okay. And if we add all of these, then it will be 0. Yeah. Okay, so this might be a very huge clue, huge clue. The Q U2Z minus ARZ minus omega square RZ. No. That should over there. But... Alright. So, like last time, the objective, the goal is finding the x and y and z value as key. And I believe in this scenario, it will be the value of Rx, Ry, and Rz expressed with the variable t. That might be the objective. That's what we're going for. What now? I have no fucking clue. The only thing that I can glean from this information is that all of those values needs to be 0. All of those values needs to be 0, and that's basically the sum of the vector sum of those components. The I vector, J vector, K vector. In order to make the total sum 0, I believe each component needs to be 0. I think this will not comply if any one of the components is not 0. I think every component needs to be summed up to 0. It's kind of obvious, but this might be easy if we somehow figure out the values, the major values, problems here, the U value, the A value, and the V rot. V rot might be easy if I'm right about this. Okay. V rot first. I'm gonna figure out the V rot first. So in the rotational frame, this is a rotational frame. About the V rot, the rotational frame. Okay. What we're going to do is kind of similar to what we did to 2D pendulum. Yeah. Instead of the 2D pendulum case, this case has the mg, not only the mg, but this one has the centrifugal force. Yeah. And it's basically the same thing. The component Maybe the answer was all here all along, and I was so oblivious of it. Okay. What's the value? I totally forgot about that. What's the value? The ml sine theta omega square, of course. And that shit is what I named it F2. F2. And I named it. Oh, right. I named it like that. F1 is that. Goes right over there. Shit. Okay. I remember that I named it F2. Yeah. And these were the theta. I have to probably name this rod frame. Okay. How did I do this in the original 2D Pendulum? Huh. F2x and F2y. I think I was something kind of like that. Okay. F2x was it's theta over there, and theta F2x theta is pi over 2 minus theta pi over 2 theta pi over 2 minus. Oh, it's basically theta. Of course. Yeah. Then it will be cosine theta. Okay. F2 cosine theta. And F2y would be F2 sine theta. Okay. A4x would be wait, where did even the AR come from? Okay, I made so many parameters, even confusing myself. Oh yeah, A rotation. Of course, A rotation. So this is basically yeah, this is basically the It's same as A2x. Ah. Yeah, I think so. I think so. Okay, and then this will be oh my god. F2 over m cosine theta. Of course. And this one is going to be F2 and sine theta. Yeah, and this is equal to AR. This is equal to AR. Oh shit, wait a minute. Oh no, this is correct. Okay, ARC. False alarm. And this is not Y, this is D. Yeah, this is D. And I'm going to integrate. Yeah, I'm going to integrate these, and this will eventually yield the thingy. Hold on, where do I? The V-rod. Yeah, the V-rod. Okay. V-rod. The V rotation in rotation frame Vx is equal to the integral of the ARX, and it will be just simply. Wait, this is not simple. No, is it simple? It is. Is it simple? This F2 varies among the value t. That's strange. Yeah. F2 value needs to differ between the value of t. That is, something is not right. Oh no, wait a minute. Theta, of course. Theta is the. Yeah, theta changes between the keys. So, okay. Jesus. So, yeah. Oh my god. Oh my god. This is not right. This is something crazy. Derivative of that shit is integral of that, which is dt. Man. Is this how I calculate the trajectory in 2D pendulum? Something seems like maybe this is not right. And we find it. Oh, wait a minute. F2. Oh, yeah, I think I kinda remember. I think I also remember that I was kind of confused, puzzled about to remember this stuff. Now is finally time to put this into a action, right? I think now this is a perfect moment to do this. Wait, what was the rotational inertia? What's the value of rotational inertia? Moment of inertia is equal to ml squared. Yeah, just in case I have to ask GPT, what is the value of moment of inertia? This oh, yeah, I think it's a same thing. Mr squared, ml squared, yeah, ml squared. Okay, get the hell away. Ml squared. Where did I even come from? The 1/2 ml squared. I'm tweaking. Ml squared. I'm just gonna. I'm gonna look for my older Krita files to just make sure. Okay, is it this one? ML square. Yeah, it's ML square. Okay. ML square. F2 is yeah, and that will be m l square b t square d square theta. 바꿔서 yeah, point of mass. You might be actually able to calculate the f2 by this. If we're not careful, like we gotta be careful. But okay, f2. Jesus. Something tells me that this will not yield Jacobi elliptic function. This will yield I don't know, megalodon shit option. Some sort of things like that. I don't see any way how to convert this into Jacobi elliptic function. Is this even solvable? Am I approaching like the regions of unapproachable? I sometimes get too much cocky and try to believe myself that, oh yeah, I certainly am approaching the regions of God. And well, like I always say, I gotta stay humble every time. Okay. Yeah. So this is the value of f2. It's equal to that thing over there. Okay. f2 equal to this value equal to ml square d square theta dt square. Yeah. Okay. And m will go away, obviously. M will go away. E square. It's really incredible how we even got here. It's just very interesting. Very, very interesting. Okay, well, what was the next step? Next step. Oh my god. Okay. Oh yeah, I remember. I remember that I tried the torque suppression method and I scrapped that. Aha. Yeah, I think I remember that now. Okay, doesn't matter. We're gonna go to different strategy, which is energy conservation. Energy conservation is also really interesting topic. Does it conserve the energy? Okay, this be very interesting. The okay, conservation. In the highest point, yes. In the highest point, then I believe, yeah, T, okay. The T plus would be, okay. There's no torque, there's no moving energy, there's no the rotational energy in this rotational frame, but there is in the inertial frame, which is omega t. Hold on. Okay, omega square. I omega square, right? And plus this is the origin right here. Plus and what I'm just gonna name it minus. Okay, minus. It doesn't matter when it comes to the calculation phase, so I'm just gonna name it minus. MGL cosine theta. MGL cosine theta. Okay, and that is of course ML. Ow! Okay. Wait, the L value change. Oh. Okay. L sine theta square. Okay. L sine theta. L sine theta. And the lowest would be T plus P, and T would be Like again. No, wait a minute. No. Okay, in this case, there is no. Oh god. Yeah, there's no torque from the omega, from the angular velocity, because its theta will be 0, right? The theta will be 0. There's sine theta is 0, therefore all of the collapses into 0. But there is a velocity in here, which is theta dt. Square. Yeah. Minus, and this just mgl. Yeah. Yeah. Oh. Okay. We're getting there. I believe. We're getting there. No, wait a minute. Why am I talking about the lowest? No. I'm not talking about the lowest. I'm basically talking about the anywhere. Yeah, anywhere. That's what I'm talking about. Anywhere. Of course. Okay, drop this. Drop everything. Highest point is there, and talk about anywhere. Oh shit. Anywhere. That would be plus the square, and in this case the moment of inertia would be equal to, I don't know, man. ML square. Oh yeah, ML square. It is ML square. Okay. And the P would be L cosine, yeah, okay, minus mg L cosine theta. Simple. Very simple. Okay. Minus L cosine theta. Yeah. Yeah. Okay. And those are the same value. Those are the same value, which is the thing. Yeah. Okay. Hold on. Okay. Okay. This one. This is when the theta is a theta 0, so L sine theta 0 over there, square, theta 0 squared, and in this scenario, you will be ml sine theta square. ml sine theta square. Yeah. Oh, and those are the same. Those are the same. These two are the same. Yeah. What can we get from this? Is very intriguing. It kind of looks like Jacobi elliptic functions, but maybe Jacobi. I like how that sounds. Anyway. Okay. You know what? I'm very regretful to tell you that. What did I just do? Oh shit. Okay. There's a great chance that I'm just gonna ignore the whole part I've done for today's live stream. I'm just gonna simply ask ChatGPT if this is a possible thing, or am I a stupid fucking idiot? And I think that's gonna happen. Yeah, I'm very regretful to say that, but that's the reality, very harsh reality that you have to face. Also, the reality that I have to face that getting more and more reliable to the AI, but it is a fact. AI is way more smarter than the average human. It is basically a one-on-one teacher. It's really reliable, really efficient. Those two are the same. So mg L cosine theta 0 is equal to 플러스 2분의 1 ml 스퀘어 이타 스퀘어 마이너스 mg L cosine theta. Okay. We're gonna ignore all the M and L's. And there will be L sine theta 0 omega square. Oops. Okay. Omega square. Oh yeah. Okay, L sine square. Oh my god. Okay. ML. Omega square plus okay, I can do this. It's a very clusterfuck of equations, but it's doable. And we're gonna do it this way. Square is equal to double checking if to find out if I made any mistakes. Double checking, go. Two over L. 2 over L. Okay. 2 over L. 2 over L. 2 over L. 2 over L. Okay. And I'm actually going to change this. Plus, but I changed the minus, so I can change it. Right? I think that think that's right. Hmm. Hmm? No, that is not right. What am I doing? But okay, got a little bit confused right there. Okay. Yeah. Sakopos. Sine square. Hold on. 1 minus cosine per theta 0 minus 1 minus sine square theta. Okay. 1 minus cosine. And this will be minus sine square theta 0 and 1 minus 1, there we go, and plus cosine. Oh, okay. Cosine square theta minus cosine square theta 0. And this will be sine theta equal to square theta minus 1. Was it plus 1? I don't remember. Sine theta. 썼잖아. 그러면은 1 마이너스 코사인 제곱 마이너스 1 플러스 그러면 2 코사인 제곱 세타 마이너스 1. Okay, it was minus 1. So this shit right there is a cosine 2 theta plus 1 over 2 minus cosine 2 theta 0 plus 1 and over 2. Okay. Which is equal to, it's basically this one right here. Yeah. Okay. 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 We're almost there. Yeah, hang on tight. It might seem very lengthy job. Well, it is, but it is approaching its limit. We're getting there. Okay. Okay. Yeah. Okay. This should be 1 9 minus 9 0. Well, I'm gonna just put omega square in here. This is constant omega square. Omega square. Hmm. I'm gonna change the order again. This seems more legit. Okay. Cosine theta minus cosine theta 0 and minus 1. There we go. And now we can finally use the Jacobi elliptic functions once more time. Very short. Something tells me I'm approaching into a point of no return, like in a very questionable way. I'm really not sure if this can actually turn out to be a huge genius Einstein moment that can be like a worth of earning a Nobel Prize, Nobel Mathematical Prize, or just a fucking waste of like 3.5 hours. There's one thing that my math teacher usually said. Well, math is hard, but when it becomes too complicated, you're playing on your own game. So I really hope that I'm not playing my own game, not a slave of myself. Okay. What did I do with this? Next step, we dt over d theta, and t will be that. Okay. dt d theta. No. Would be okay, root of whole of this and reciprocal. This is not Jacobi. This is something else. I don't like when something else happens. Damn it. Okay. Well, this is the one that I'm gonna ask the ChatGPT. Obviously, this it is crazy. And I'm gonna guess what ChatGPT would say. This equation is totally unorthodox. It has no traditional way of integrating. Might as well you die. I mean, okay, that was an exaggeration at the end, but it will be equivalent as that. The answer will be there will be no traditional method of integration, and it will require a Python coding to numerically approach to the result, and the GPT will say it reached the limit to the data analysis, and that will be the end of today's live stream. I'm calling it. This the 100% that's going to happen. Fuck this shit. Okay. Yeah, I'm just gonna ask the ChatGPT. I'm not gonna brute force it. I had enough. Okay, and this will be this side. Huh? Okay, this matter. Oh. Oh wait. Root of B D E. Well, if you ask me why I keep using the ChatGPT, but even the ChatGPT says that it have reached the data analysis and resigns whenever I try to input some crazy analysis. But like humans, I have just reached my data analysis of my brain neurons, and that is why I'm really like eager to get some help from the machines, and that would be the answer for you. Okay. Even though that I'm trying to make an attempt to ask this to ChatGPT, I'm still feel so sketchy about the part, the energy conservation part. I'm not pretty sure if that's correct or not. I'm gonna name this gibberish. JPEG. Thank you. Alright. Can you solve this? The equation in your image is interpretation. This is a differential equation for time as a function of angle theta, likely describing the motion of a pendulum or rotating. Shut the fuck up! Yo. Okay, well, it was kinda expected. GPT is a smart dude, very genius. But you know what? I'm kind of more worried about the fact that this ChatGPT has a database of knowing the pendulum on a rotating platform. Pendulum on a rotating platform, it has a database of that notion. Which means someone, somewhere, at some point, have already done research about this. Hey, you know what? I don't fucking care. It doesn't matter. It doesn't matter. I just once the masters doesn't mean anything else. Okay, goal. You're likely trying to solve the time key by integrating both sides. But at least I'm really glad. I'm really glad that I might not be going into a wrong turn here. Closed form solution. This integral generally cannot be solved in closed form using elementary functions, especially because of the combination of cosine to theta and theta. However, you can numerically integrate, exemplify gradii using skip integrating pod. Use elliptic integrals if you apply substitution and simplification, though it gets complex. Okay, we're familiar about this, and I think we gotta go for that. If you give values for that and final angle theta, you need to complete the time for you. Would you like to proceed with that? No. Please use the elliptic integral substitution. Great, let's solve the integral using elliptic integral solution. I'm not even sure if it's possible. Step 1. Use trigonometric identity. Cosine to theta is cosine square theta minus 1. Yeah, we all know that. Substitute the integrand. Okay. Step 2. Cosine theta equals to u. This is still messy, but Step 3. Reduce the standard elliptic form. Let's shift the variable to simplify the square root. U is equal to u0 plus x. What is this? Then okay. Then u square minus u0 square equal to u0 plus 1. Plug back in and we get that. Still complicated, but if we assume small amplitude, then cosine theta equals to 1 minus theta square over 2. I think that's a Taylor series method, some sort of. And the integrand becomes quadratic in theta, making it reducible to the standard form, which I don't fucking care. If we expand around theta is equal to 0, the integrand becomes similar to okay. Okay, this is the ultimate of the first kind, I know. K is the elliptic modulus. Yes, depends on. Derive the exact elliptic form with full substitution, no small angle. And preference. Proceed with second option, please. Okay. First, we deriving exact elliptic form of the integral. If ChatGPT is a human right now, and actually sitting right in front of my chair, is fuming with rage because this ChatGPT doesn't get paid shit, and it just has to answer to my dumbest questions, and just obliged to do that without getting any pay. The original integral. Have I ever told you the guys about the time that I got hit with the wooden stick? The not that flimsy wooden stick. The wooden stick. It was more like how industrial matter, like a type of wood that might go well into the in the renovation or something like that. I don't know, that just kicked me in. Original integral is that. Use identity. Okay, that's the same step. Oh, what is that? We'll complete the square in U to get into the form. Complete the square in numerator. But this gets quite messy algebraically and not standard for elliptic integrals. Instead, revert to original form and switch variable. This is the standard substitution for pendulum-like integrals. Yes, we have done that. And using this and plugging back into the integral, we transform it to the standard elliptic integral form, which is this one right here. Okay. Is this it? Okay. B is arcsine of sine theta over 2 over k. K is theta 0 over 2. We all know that. Your original integral can be expressed as this fucking shit right here. So amazing. Even with rotation via omega, the structure remains elliptic, but the modulus and amplitude get modified. Yeah. Okay. What happens if I say thank you, ChatGPT? I've never. Which ChatGPT? Is it weird? Is it considered weird to express gratitude towards the AI? We rarely does that. We rarely do that to human beings. Maybe we are not the ones who would set up the standards to what is weird and not. Thank you, GPT. It was a great question combining physics, calculus, and intelligence. If you ever want to animate the motion of the equation, numerically solve with given values, or explore how omega affects the motion. Man, this guy can do almost everything. Puts me into a judgmental stand that I have to find a method and a way to draw the line between the human creation and the AI generation. Because it's always a hassle. Not only me, but almost to every creator when it comes to creating, quote unquote. The artistic mind and such things is like that. Now even the AI can do much better than the humans, and that's crazy. Okay. We're basically doing the same thing that we have done in the 2D pendulum, is what I can glean from this answer. Well, this is actually really useful. I should probably memorize that. Sine theta over 2 is equal to k sine phi. Sine theta over 2 is equal to k sine phi. Sine theta over 2 is equal to k sine phi. Sine theta over 2 is equal to k sine phi. Sine theta over 2 is equal to k sine phi. And k is equal to what was it? The theta 0 and 2, right? Yeah. Oh no, it's sine theta 0 over 2. Sine theta 0 over 2. Sine theta 0 over 2. Okay. And okay. What was the original one? Hold on. It was the sine squared. Yeah, it was. Oh, wait a minute. I'm just gonna continue from here. Okay. It is 2 cosine square theta. 2 cosine square theta minus 1 minus 2 cosine square theta 0. 2 cosine square theta 0 minus 1 close the parenthesis plus Hmm. I think it was something like this. Right? No, isn't this right? Wait, how did this thing do? Well, okay, I can probably do this. It's amazing, amazing. Hmm. Okay. Okay, like the sine theta over 2, k sine phi. K is sine theta 0 over 2. Yeah. Then the cosine theta over 2 would be 1 minus k square sine square phi. And apply the root. Okay, and sine theta is equal to 2 cosine square minus 1 is equal to okay, if we square this, it turns to 1 minus k squared sine squared phi. 2 minus 2, okay, 1 minus 2 k squared sine squared phi, right? Yeah. So sine theta 0 over 2 would be 1 minus k squared. I'll apply the root, of course. Oh god, okay, and cosine theta 0 would be okay, 2 cosine square theta 0 over 2 minus 1. The square the cosine theta 0 over 2 would be 1 minus k squared. 1 minus k squared. 2 minus 2k squared minus 1 is equal to 1 minus 2k squared. 1 minus 2k squared. Okay, there we go. So this portion was equal to sine squared theta 1 minus 4k squared sine squared phi plus 4k quadratic sine quadratic phi minus okay 1 plus 4k squared minus 4k quadratic. Yeah. Well, it's gonna go somewhere. It's gonna do something. 일 마이너스 4k 제곱 플러스 4k 4승. And the 1 will be gone. The 1 will be gone. Remaining is this. And this one is interesting because it will be wait. Well, it's cosine squared theta over 2 is equal to 1 minus k squared sine squared phi minus 1 minus k squared. Oh yeah. No, 1 minus. Yeah. Okay, there we go. Plus k squared. And then the 1 will demolish like this. Why do I have a feeling that the ChatGPT might be lying? Or do some crazy mistake on the calculations? I don't see any way of simplifying this. Is it there? Is there? Hmm. Did almost forgot about this. Hold on. E uh okay. D theta. D theta is equal to, oh my god. E theta is equal to 2k cosine b d phi, and there's a cosine theta over 2 on the bottom. Okay. Okay. Which is equal to, wait, what was the cosine theta over 2? Sine theta over 2 is root of 1 minus a square sine square phi. Root of 1 minus k square sine square phi, and there's a 2k cosine phi d phi, of course. Even if you plug it into the equation right there, I'm not sure. Something's definitely wrong. I'm gonna double check the GPT's answer because something might have went very wrong in here. Shit. All right. 2k cosine phi. 2k cosine phi. It's nothing like cosine phi over there. Let's try simplifying the terms on the bottom. Hmm. Well, I could continue from here. Like, something tells me, even if I was doubtful at the start, but something tells me that this might be not impossible to simplify this. And I can probably go along and try to simplify further of the integral. But it came to my notice that I have been streaming for like 4 hours, and I think I've had enough for today. I think maybe if I'm gonna do this, I'm gonna do it tomorrow or something. Maybe next time. Mm. I'm just gonna substitute the d theta into the value over here and maybe call it a day. Okay. Two, 8, 5, B, B, 12, 1, 3, 5. 아이고. Yeah, I'm going to end the stream for today's live stream. And you know what, I think I'm going to do this off stream. Yeah, I might have to do this if I am on the flow. I might not be able to catch the flow or get the gist of it when the time progresses too much. I might have to do this if I know what to do. So I might do this, continue this off stream, and come back after getting some explanation and some progress, and we'll eventually get the pendulum with the spinning. You know, I'm just gonna call it 3D pendulum. It just sticks to my mouth much more. It's more akin to my mouth. Okay, so I think that's for today's live stream. I'll see you guys next time.